Hey, Honors Geometry. We are going to talk today about parallel lines in 2.9, and then in 2.10 we are going to talk about perpendiculars and distance in the coordinate plane. So let's get started with 2.9. 2.9 is kind of along the lines of what we've already talked about with parallel lines. All these words should look familiar to you because we have learned these theorems before. All right. Now the difference between what we're doing today versus what we did last time is that last time, for example, when we were talking about the alternate interior angles theorem, so let's write that down. Try to write small here. Alternate interior angles theorem. All right. This theorem said that if I have parallel lines, so for example, if you have parallel lines with a transversal, then we know that alternate interior angles are congruent. Okay, so notice how the hypothesis is if we have parallel lines with a transversal, conclusion is that the alternate interior angles are congruent. Today what we're talking about the converse of these theorems. So the converse of the alternate interior angles theorem. All right, the converse would say if alternate interior angles are congruent, then the lines are parallel. All right. All right, so that's the basic idea. All right. Obviously, it's literally just the converse, right? We know from the previous sections that converse just means you switch the hypothesis and the conclusion. So we use the alternate interior angles theorem when I know lines are parallel and I'm trying to prove angles congruent. I use the converse when I know angles are congruent and I'm trying to prove lines parallel. So there is a difference between the two. It's just depending on what you know and what you are trying to prove. All right. So in these two proofs, go ahead. You can pause the video if you want and write down these two proofs here. I'm just going to start with the second one. It's a little bit easier. So why don't you pause the video and write down this one. And let's actually try this one together. I know that recently I've been giving you the statements for all the geometry proofs, but eventually we are going to have to write an entire geometry proof on our own. So let's get some practice with that right now. All right, so this first one, obviously my first statement and my first reason, that's just going to be the given. All right, so this information would just go right in there. I'm not going to write that, but you should write that there. Second, again, I'm trying to work towards showing that L and M are parallel to each other. All right, right now we do not know that. All we know right now is that 1 and 3 are supplementary. Okay, so from here, what we could do is we could start probably trying to talk about some other angles. So I'm going to talk about 1 and 2. And so that I know that angles 1 and 2 are supplementary. All right, the reason I know they're supplementary is because they're a linear pair, right? So by the definition of a linear pair, I know that these two angles are supplementary. All right, it's tempting to say that they add up to 180. I get that temptation, but we don't even need to talk about their values. We can just say that they're supplementary. The reason why is because in step 3, since 1 and 2 are supplementary and 1 and 3 are supplementary, it's almost like the transitive property with supplementary angles, right? We talked about that a little bit earlier, right? Since 2 and 3 are both supplementary to angle 1, we know that angles 2 and 3 must be congruent. All right, so angle 2 has to be congruent to angle 3, and the reason is that two angles supplementary to the same angle must be congruent. So we know that angle 2 and angle 3 must be congruent to each other. You know I like to mark up the picture whenever I learn something, so we know 2 and 3 are congruent now. And now that I know 2 and 3 are congruent, again, my prove is to try to prove these lines parallel. So again, thinking about this, the regular theorem versus the converse, we're going to have to use the converse, right? I'm using the converse because we know angles are congruent. I'm trying to prove parallel, all right? So the converse of what we originally learned with the other theorems, right? And again, you do have to choose the appropriate theorem. You can't just always do alternate interior angles, right? You have to look at the actual angles that you have. So when I'm looking at angles 2 and 3, angles 2 and 3 are corresponding angles. So we know that L is parallel to M, and the reason why is the converse of the corresponding angles theorem, right? Because 2 and 3 are congruent to each other, we know that L must be parallel to M by the converse of the corresponding angles theorem. All right, and that is it for that proof. All right, not too bad. Next up, we have this proof here, which is not necessarily harder. It is a little bit more algebra involved. So again, like I said, you're typically going to start with all the geometry reasons and then work your way into the algebra reasons. So first off, we do have our given, right? And again, you should write all of that right there. Second, all right, now we know that 1 and 2 are congruent to each other. All right, so if 1 and 2 are congruent, I can basically already start to say right now that L and M are parallel, right? So L has to be parallel to M. Again, this is because 1 and 3 are corresponding angles. So because 1 and 2 are corresponding angles, so because 1 and 2 are congruent, this is just the converse of corresponding angles theorem. All right, because those two angles are congruent, we know that L and M are parallel. So I'm going to mark L and M parallel right now. All right, well, it's nice because now I know that these are parallel lines, which is helpful because eventually I want to work with angles 2 and 3, right? Because we know information about 2 and 3. I'm eventually trying to work 3 in there because I'm trying to prove information about angle 3. So what I would do next is I would probably talk about angles 2 and 3. And we're going to say that angles 2 and 3 are supplementary. All right, we know that they are supplementary because they are what kind of angles? They are same side interior. All right, so again, we're not using consecutive here, we're using same side interior. All right, so you can change that up there. That's same side interior, same side exterior. All right. All right, those are same side interior angles. All right. So again, it's tempting to say that they add up to 180 already at this step right here, but we can't say that they add up to 180 yet. All we know is that same side interior angles are supplementary. But now that we know that they're supplementary, now we can go ahead and we can say that the measure of angle 2 plus the measure of angle 3 is 180. All right. And we know that that's 180 because that's just the definition of what it means to be supplementary. Right? So it's kind of tempting to skip this step and jump right to step 4 there, but you really are not allowed to do that. You have to take those 2 tiny steps there. I know it's annoying sometimes, but you have to first say that it's supplementary, and then you can say it adds up to 180 because that's the definition of supplementary. All right. So now we're going to go ahead and it looks like we're going to do some substitution, right? Take that 3x plus 8 and plug it in. Take the 5x plus 12 and plug that in as well. So now in step 5, we've got 3x plus 8 plus 5x plus 12 is 180. That is substitution. All right, we're going to go ahead and simplify, or in other words, combine like terms. All right, so this is going to give me an 8x plus 20 equals 180. All right, I ran out of room, so I'm going to erase this stuff down here and kind of continue down here. All All right, next up is step 7. Looks like I'm gonna wanna move the 20 to the right side using subtraction. That would give me 8x equals 160. So that's the subtraction property of equality. Step 8, we're gonna divide both sides by 8. That's the division property of equality. And now that we know what x is, we do want to figure out what the measure of angle 3 is. All right, so we're going to go ahead and we're going to take that original statement that we had up here, right? Measure of angle 3 equals 5x plus 12. So we're going to say that the measure of angle 3 equals 5 times 20 plus 12. All right, this is just substitution. Right, I'm plugging in that 20 for the x value. And then last thing we're going to do is just simplify. 100 plus 12 is 112. All right. You could also write combine like terms for this one because numbers are like terms, so you are technically combining like terms. But that's going to be it. All right, we made it all the way to the end. We found out what we wanted to prove, which was right there. And so we are all set. All right, so again, hopefully you kind of were pausing this video and trying it on your own and not just writing down what I was doing. All right, hopefully you're thinking for yourself on these because, again, even though I've been giving you the statements and you just have to do the reasons, on upcoming tests and quizzes, I'm not going to give you any information. It's your job to figure out all that stuff. All right, but again, notice all of the geometry happened right up here, and then all the algebra happened after. And that's typically common with proofs, is that you're going to get all your geometry information out there first, and then you're going to be able to work with it using some algebra properties. All right, so stay tuned for the next section, which will be 2.10.